Okay, now now consider the jump question, 1994 question 8. The diagram above shows a uniform wood of weight 200 Newton and length 50 meter. It is pivoted at one end and suspended by a cord at the other end at an angle of 30 degrees to the wood. Calculate the tension to the cord if the wood is horizontal. Now we have four options. We have four options, and at the end, one will be good for the solution. One will be good for the solution. Now, looking at the diagram, there is a pivot at this end here. It means that this is the point of rotation, and at this point, we have the axis of rotation. At this point, we have the axis of rotation. This is the axis of rotation at this very point here. This very point here. Now, this one will now lead us to static equilibrium. Now, for static equilibrium, there are two conditions that must be fulfilled. Please take note. For static equilibrium, there are two conditions that must be fulfilled. Meaning that the first one is that the net force must be zero. The net force must be zero. And also, the sum of the torque will also be zero. Take note, the sum of the torque will also be zero. It means that these are the two conditions that must be fulfilled under static equilibrium. Now, we'll be using these two conditions to resolve this very diagram of this system. Now, looking at the first condition, which is the net force equals zero. Now, what can we really do? Meaning that we have to resolve the system into components. It means that this one will be y component and this one will be s component. Okay, now, and we are dealing with a case of a cord at this end here. Now, whether for cord or wire or strings, it means that tension force exists in it. It means that for this cord now, we have tension force. Therefore, here will be T. And of course, we're asked to look for the tension. They calculate the tension in the cord if the wood is horizontal. Now, let us consider this first condition. Of course, the one that has to do with the net force. And don't forget that this one has to do with translational equilibrium, while this one has to do with rotational equilibrium. Okay, now, looking at the first condition, that is the net force equal zero. And that one will now lead to some of the forces in the y and also some of the forces in the x. Okay, looking at this very one, okay, let us interpret this very diagram made to explain this. Now, how can we really do it? It means that this t here will have effect here, and this t here will also have effect here. It means that for this t, it will be it will have effect, it becomes t sine 30 degree, okay, and this one will be t cos 30 degree. Okay, now we have a complete system now. We cannot proceed. Now, to solve this very one, I have to consider the first case, which is the net force. And don't forget, for under that net force, we have some of the forces in the y. It means that sigma Fy, and let us see the one that is y component. This one is y, this one is y. It becomes t sine 30 degree, which is positive. Look at the arrowhead. It is upward. Look at it here, it is upward. Now, for this one, it is downward, therefore, it will be negative. This one will be minus 200. Now, don't forget, under net force, the sum of the forces but in the y must be zero. Therefore, here is zero, become equal t sine 30 degree minus 200. Okay, now, taking this one over, it becomes t sine 30 degree, okay, equal 200. Now, what is sine 30? Sine 30 is simply 0.5 equal 200. Now, divide both sides. If I divide both sides by 0.5, I will have 200 over 0.5. Let us see what we have there. Therefore, we are going to have okay, let us see. We are going to have 400. Please use your calculator and do that. We're having 400 in the tension force. You mean that the tension force is 200. Use your calculator and try that. Then 200 divide 0.5. We are going to have 400. 400 will be your answer. Okay, now look at okay, let us look at the other one under net force. We also have some of the forces in the x, some of the forces in the s, and some of the forces in the s. What is the horizontal component here? This one is horizontal, therefore become t, and it is positive. Look at the arrowhead, become t cos 30 degree. And when we look at this very one here, okay, looking at the diagram, it's only one component we have there, and it just t cos 30 degree. Now, don't forget for this one, we have here as 0, the sum of forces in S must be 0. Fulfilling this very condition, net force. Okay, now for this one, I will have t cos 30 degree. Okay, divide both sides by cos of 30 and we have t, which is 0 over cos 30 degree. Okay, 0 dividing cos 30 degree, I'm going to have 0 here. This one will be 0 Newton, this one will be 0 Newton. Okay, now that one is for phi now, then the first condition is for phi. Now looking at this first condition, let us now see the solution. This one will be the first solution, is 400, and this one is 0. Now looking at the option, we have such here, we don't have such here. It means that this one, we cannot take this. We cannot take this very one. Using the first condition, it means that the answer does not even correspond with the options. Therefore, this one is not taken. Meaning I will have to now look at the second condition, that is to say the sum of the torque. The sum of the torque must also be 0. Please take note, the sum of the torque will also be 0. Look at the condition 2. Now, okay, now let us consider this very diagram again. It means that if this one is the force here, this one is the force, this one is the force. Now, if I should apply a force upward, look at the arrowhead, it is upward. It means that this very system will move up like this, it's going to turn like this. It means that this one here will turn in this manner, this very force will turn in this direction, and it will produce a positive torque. Take note, it will produce a positive torque. Let me call this one T1, T1. Okay, while for this one, look at the arrowhead, it's downward. It means that if you apply the force down like this very system will move in this direction, it will move in this direction, and therefore this very force will produce a negative torque. Take note, it will produce a negative torque. Let me call this one T2. Now from here now we can now proceed. Now I can now say some of the torque. Now which one is positive? T1 is positive. The guy to say T1. Now this one is negative minus T2. Now don't forget from the condition here we have some of the torque equals 0. Therefore this one will be 0. Okay, and then we have T1 minus T2. Okay, taking it over, we have the T2 equal T1. Okay, now let's see now. Please don't forget for torque, we have the product of force and distance. The product of force and distance. Okay, now we can now apply this very formula in this very one here. Now apply this one, let us see. Please don't forget that in the question they said the diagram approach shows a uniform root of weight 200 Newton and 50 meter. It means that this very hook is 50 meter, and look at the position of this force. It's at the middle. It means that here will be 25, here is going to be 25, okay, because they are equal. 25 meter, and this one will also be 25 meter, okay. This one here will also be 25 meter, okay. Now let us now see what we can do here now. It means that for this very one, okay, one will consider the first one, which is this very one, T1. Now it will move, in this direction and cover the distance 50. It means therefore now, okay, let us consider T2 first. T2, okay, T2 now will be this one. If this one should move like this, meaning it's going to cover just one distance, this very one, and this is the axis of rotation. Therefore, for the T2, I can say 200 times 25. Okay, let us now consider the other one there. Let us consider the other one. And this one, this T2, using this very one, force and distance. Okay, the force there, what is the force there? For this one, this is the force. Okay, now it will turn like this. And when it turns, it will cover a distance of 50. Therefore, it will be T sine 30 degree times 50. Okay, now looking at this very one, I can divide both sides by the coefficient of T. And the coefficient of T here is sine 30 degree and 50. Okay, now dividing both sides, the of T equal 200 times 25 all over sine 30 degree times 50. Okay, let us see. Now, what is sine 30 degree? Sine 30 degree here is 0.5. Please take note. Sine 30 degree here is 0.5. Therefore, we have 0.5 times 50. Okay, now doing this one here, Okay, let us see what will happen here. It means that for this one, I can say, for this one, I can say that T equal 200 times 25 all over. Now, when I use 0.5 to times 50, I will have 25. I'm going to have 25. I mean that 25 here can keep 25 here. Therefore, our answer will be 200 Newton. Okay, it means that from the options, we have 200. Look at the options, we have 200. Mean that this second condition will fulfill this very, it will meet this very, this very question. Mean that this one here, this condition 2, will solve this very question. Okay, now we can accept this very condition that this one is accepted. Okay, I can now conclude at this point and say all the best. Now the option is D. I can say all the best. Okay, thank you for joining me on this platform. Please don't forget to like my page, JB Jumbo on Online Mathematics. That is my Facebook page, JB Jumbo Online Mathematics. While my YouTube channel, okay, also subscribe to it, Mathematics Science Mega Tutorial. All the best. God bless you.